Derivative control mode. Continuous controller modes part 3. Suppose you have a screen that shows the variation of error in time and that it looks like figure 16. You can clearly see that though the error at t0 is 0, it is changing in time and it will certainly not be 0 in the following time. Therefore, some action should be taken even though the error is 0. This scenario describes the nature and need for derivative action. Request. It is hoped that this lecture is going to be useful to you. Please press like. Please subscribe. Derivation controller action responds to the rate at which the error is changing, that is, the derivative of the error. Appropriately, the equation for this mode is given by the expression p as a function of time equal to k subscript d derivative of ep with reference to time. This is the expression, where the gain k subscript d tells us by how much percent to change the controller output for every percent per second rate of change of error. Derivative action is not used alone because it provides no output when the error is constant. Derivative controller action is also called rate action and anticipatory control. Derivative mode controller action changes depending on the rate of error. Figure 17 illustrates how derivative action changes the controller output for various rates of change of error. For this example, it is assumed that the controller output with no error or rate of change of error is 50%. When the error changes very rapidly with a positive slope, the output jumps to a large value, and when the error is not changing, the output returns to 50%. Finally, when the error is decreasing, that is has a negative slope, the output discontinuously changes to a lower value. Here we can say when the error is 0, the output is 50%, the rate of rise of error is here, so it jumps, output jumps, and then the rate comes down, so the output jumps down, then the rate is constant, the output is again at 50%, and when the rate is negative, the output goes to negative value. that is less than 50% value. And again, when the error is 0, the output is at 50%. The derivative mode must be used with great care and usually with a small gain, because a rapid rate of change of error can cause very large sudden changes of controller output. Such an event can lead to instability. Let us summarize the characteristics of the derivative mode and equation 18. If the error is 0, the mode provides no output. If the error is constant in time, the mode provides no output. If the error is changing in time, the mode contributes an output of k subscript d percent for every 1% per second rate of change of error. For direct action, a positive rate of change of error produces a positive derivative mode output. Request: it is hoped that this lecture is useful to you. Please press like. Please subscribe.